Okay, so let's just continue for a little bit here, and we'll start talking about bringing all of this into chemical terms. So we've done the cookies, we've talked about tricycles, now let's talk about chemicals. And this whole idea of balancing equations was to prepare you really for this. I want you to balance this equation. N2 and H2 goes to NH3. It's an old thing to do, but really what this was all about was making your recipe. So let's go. We have N2, so we need 2 of these, okay? And that means we now have 6 H's, and now I need 3 of these. It's always a good example, this one, because it gives you 3 different coefficients. So of course there's a 1 here. You don't have to write it, but I'm going to for now. And that's what this means. It's a recipe. It says for 1 nitrogen and 3 hydrogens, you get 2 ammonias out. And it's like saying 1 cup of sugar, 3 cups of flour, you get 2 cookies. Okay, it's the same thing, but now we're dealing with chemicals. What can we learn from this? Well, we can learn how much ammonia can be made. Ammonia, if you don't remember, is NH3. I think you do, but whatever, how much ammonia can be made. You can also learn how much hydrogen or nitrogen is used given a certain set of circumstances. So, for instance, let me give you this example. You see what I mean? How many molecules of ammonia could I make from 5 molecules of nitrogen and 15 molecules of hydrogen? Let's think about this. So 5 molecules, 15. So it's almost like I'm multiplying the recipe by 5, right? I'm going from 1, I've got 5 molecules, and I got 15 of hydrogen. You should be able to figure out then how many molecules of ammonia could I make from that. You're going to do that as part of your homework tonight, so go ahead and do that. Let's change this into moles. How many moles of ammonia are produced when 0.6 moles of nitrogen react with hydrogen? Now, I'm going to rewrite the equation here, balance, just so that we have it on this page. Now, at this point, you are to assume that we have enough of everything. So if I tell you that there are 0.6 moles of nitrogen reacting with hydrogen, you're supposed to assume that I have all the hydrogen I could possibly need. So if I have 0.6 moles of nitrogen, the question is, how much ammonia could I get? Well, this is looking just like that tricycle example when we set up those proportions. You can do it that way. I'd like you to set up the proportion with moles of nitrogen over the 0.6 moles of nitrogen, and then moles of ammonia over the X moles of ammonia that you're going to produce, and I want you to go ahead and do it. Now, I know some of you can look at this and see it, and I'm going to show you how, in case you don't, how you could just see it. Look, the ratio of nitrogen to ammonia is 1 to 2. So you need 2 times as many molecules of ammonia as you start from nitrogen. So how many moles of ammonia could you make from 0.6 moles of nitrogen? If you see it, go ahead and write it down. Either way, I'd like you to do it by proportion, and I need you to do it by factor labeling. Remember, with factor labeling, the first thing you do is you write down what you were given, 0.6 moles of nitrogen. You got to multiply it by something that's going to give you moles of ammonia at the end. So once again, you need to think about what belongs in the numerator, what belongs in the denominator, and what numbers you'd have to put here in order to get moles of ammonia at the end. Use the recipe, use the equation to figure that out. Now you need to see those setups, both proportion and factor labeling, in your homework. If you see it because you see the 1 to 2 ratio here, then great, you'll know what the answer is. Okay, but I still need to see the other setups. Okay, you needed mole ratios for this reaction, just like the tricycle example. If you can do this, you actually have done just about everything that the Regents would expect you to do. We'll do more stuff for pre-IB, but the Regents level on stoichiometry is actually quite short. When aluminum is exposed to air, it reacts to form a compound. It reacts with some part of the air. Well, it's kind of here, so write down what the name of that compound. Aluminum what? Right, that's part of your homework. Balance this equation. Don't worry about the sum ratios piece. That's just to help you see stuff. Balance this equation. And then I want you to answer just this first question. how many moles of aluminum are needed to form 3.7 moles of aluminum oxide. You can do this with seeing it once you have a balanced equation. If it's not balanced, it won't work because that's not a full recipe right now. I'm telling you, you're going to have to balance this first. You can do it by proportion method. You can do it by factor labeling. If you see the ratio, you can go ahead and do it that way. I only want you to answer this question. Okay? Please don't go on. In fact, if I see you answer the other two questions, you're going to get points off. Ha! There we go. Okay? So please don't do that. Now, after you're done with that, and you can press pause and do that, we're going to go on to the homework sheet. So press pause, but then I want you to take out your moles and stoichiometry regions sheet. Looks like that. Okay, presuming that you are there, I'd like you, so you can look, there are lots of different types of questions here. Some moles questions, just moles to grams type stuff, pretty easy stuff, empirical, molecular. We'll talk about those in a little while, but I want you to try and do number 13. Okay, it gives you the balanced equation, and then what is it asking? What is the total number of moles of oxygen? How many oxygen moles will you need to completely combust 1.5 moles of propane right here? So instead of having 1 to 5, it'd be 1.5 to something. I'm not going to tell you what that is, but it's one of these choices, obviously. It's a multiple choice question. So go ahead and answer just number 13 also, and then we'll be set. And if you can do this, you're in really good shape. If you can't do this, you'll be able to, I promise. Go back and think about it as flour, sugar, and cookies. That might help you, especially if oranges and buckets helped you for the moles and grams. Okay, so that's it. Thank you so much. Bye.